Hello everyone, FunshineX here, and this is another ComputerCraft tutorial. This is a follow-up to the last video on how to use and develop custom APIs. So if you haven't seen the 10th tutorial in my series, you should go watch that one now, especially if you don't know what an API is or how to create one or use one. And what we're going to do in this tutorial is continue to develop our turtle API called the turtle shapes. And what we started doing last time is defining a set of functions for our API called draw line, square, triangle, and circle. And then we're going to fill these in now with code so that we can actually tell a turtle to go and build various shapes. And the first thing I need to do is change this one to a rectangle because, as someone pointed out in the comments, squares don't have a length and a width. They just have, well, a length, basically. So, well, what do we do with a square? Well, we can still draw a square. And all we're going to need is a length and maybe a plane. And all we do on that one is just say draw rectangle, length, length, plane. So we're just passing the length as both the length and the width for the rectangle. So, cool, one function completely done, right? Okay, so in this one, another thing I was doing is I had an error when I tried to run this statement with concat, and I inadvertently did just one dot, and it's actually two dots. So let's do this. Save and exit. And do line. So now it's doing a length 3, so I missed a space in there, but that's fine. Oops, wrong one. Okay, so now let's actually make him draw a line. So for the turn X number of times, if dir is the direction he's facing, if that's 0, that just means go forward. If it's 1, it means turn right one time, turn right one time, whatever. So we're going to do a loop and say for I equals 0 to the amount of dir, and that should say turtle dot turn right. Is that the actual API? Let me get the wiki open real quick. Okay, got the wiki up just to make sure I type everything right, and that's good. So for I equals 0 to 0, this should be okay. I'm not sure if it'll turn the first time. Let's try it out. Always test, right, if you're not sure. So he's going this direction. And if we tell him to go straight, he shouldn't turn at all. Oh, he did one turn. Okay. Edit. So let's do a 1. Now he didn't turn. If we do 3, he should be facing the original direction. 1, 2, 3. Perfect! Okay. So now we can specify a value 0 through 3 to make him turn. Forward, make him do a complete circle. Okay, cool. So that's good. What I want to do now is yeah, that's fine. Let's change this back to 0, so I'm going to go straight. Oops. And I can delete this debug statement here. Okay, so we've got the turning done. Now we want to loop from 1 to length. So let's say, let's just call it J this time. And we really don't need this increment because a for loop automatically increments the value of j. Oops. Okay, move forward to place a block. That's as easy as turtle.move. Or forward. I always get that one wrong. And turtle dot place. And that would place it in front of it. Let's place it above it. That's fine. Okay. And now I'm going to copy ts to this ts. Just make sure it made there. Cool. Just to keep a copy of it because we're going to break the turtle, but I don't want to lose a program just in case. Does this turtle have a label? It does, cool. Okay, well then we can go ahead and give it some material. And go ahead and tell it to run its line program. Oh, we don't have any fuel. So normally we would need to give the turtle fuel and write some refill program in there. I'm just going to go into the config file and turn fuel consumption off just for the demo purposes. Be right back. Figured I might as well show you guys where that was just in case anyone wanted to know, but if you go into your .minecraft, go in the config folder, go to mod ccturtle.config, and turtle needs fuel, just set that to 0. Okay. Okay, we're back. So let's give our turtle another test. 1, 2, 3. Okay, and is that what we want? Really, he moved forward one first, then placed a block. I think we want to just start at the origin, so let's edit our program again. Should be able to break him. And because we labeled him, he'll still have all his programs on there. So let's just change the order here. And run him one more time. Perfect. Okay, do we want him to do that last forward? No, he should probably just finish. Right, because if he started here, he only needs to go forward twice, but place 3 blocks. So how are we going to do that? Let's see. And we can say if j is less than length, then move forward. If not, this should be good. Perfect. Okay, so now if we edit our actually testing program, let's do a turn to the right and draw a line. 1, 2, 3, looks good. And let's turn to the left and draw a line. So left is 3, obviously. Perfect, length 3. And the last one, let's turn around and go backwards and draw a long line. So you can see we haven't written a ton of code, but really to draw a line now we only need one line of code. And now he's not digging, he's not really placing it at the same level, but that's what our API does. We can say, if you want to use our API, it'll draw a line for you above the turtle of any length and any direction, as long as the pathway is clear. That's what our API does. All right, let me get him back where he belongs. And let me clean up this wool real quick. Okay, so now we want to draw a square. So I'm going to go ahead and do always do that. Just to get him out of the way so he doesn't run into that block. And so all we need to do for our square is draw a rectangle. All we need to do for our rectangle is we're going to draw a line 4 times. And I'm going to ignore plane right now and just draw a flat one. But let's say for I equals 1 to 4, because we do 4 lines. Draw line. And we're going to do it I guess the first one he wants to go straight, right? So we can't really do 1 to 4. That's fine. Because only do 4 lines of code. So first he's going to go straight for the length, then turn right and do the width. Turn right and do the length again. Turn right and do the width again. He should be back where he is. And then we might as well just call turtle dot turn right. Just so he's facing the same way. Load up our API. ts.draw square. And let's say size 5, and we don't really care about plane right now. Okay, he didn't place anything, but he did do a square. He didn't place because in how many blocks? Do you see how the power of APIs, we wrote a couple functions and now our turtle has all this power just from one line of code. It can do a square for us. Let's do it size 10 this time. Just leave a little more wool. Or we can do it with something else. Okay. Let's let him finish there. So you can see, we've done simple functions, a line, a square, a rectangle, and, we could improve our API to maybe do a filled square, a filled rectangle, and he'd go in and fill all this space for us. Or maybe, I was talking about doing it on a different plane, so instead of doing a flat square, you could just build up like this, right? So I'll leave that as homework for you guys. It's pretty easy, just you gotta kind of change how he builds, because instead of building above him, he has to build kind of below him, or to the side. I don't know. Okay, no problem there. What's next? Oh, we might as well do a rectangle just for fun. Load API again. And ts.draw rectangle, width of 3, length of 3, width of 7. Let's give him a different block real quick. Crazy designs. Awesome. Alright, let me clean this up. Okay. Third one, or fourth one, I guess, technically, is draw a triangle. So this one's a little more tough, so we might want to outline it. So he's going to go along, place blocks above him, and let's say that's going to be the length. And then we're doing a right, so the width would be here. Now the tricky part is knowing, let's make it a little more distinct here, knowing how many to go back so that it works out to get there. That's not a very good triangle at all. So obviously, maybe it's like 1, 2, 2, 1, 2, or something like that, you know, or maybe 2, 1, 2, 1, 2. So for this triangle, it's like that, but for other triangles, it might be different. So we need to know how often we need to go down for every one we go over or go back. So I think we can just divide it and say divide the length by the width. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. So 10 divided by 7 is just going to give us 1, right? 1 point something. And if we round that, he would just go down 1 every time. Something like this, and it wouldn't line up. So we need to get the remainder using the modulus function. And if the mod is greater than 0.5, we'd go to the next row. If it's less, then we'd stay on the same row, I think. Let me think about the math real quick. Okay, so the algorithm for drawing a line with pixels, finding the closest pixel, is you take the divide the two together. So the change in height, or the change in x coordinates, or the change in y. So 10 divided by 7, and we'll get 1.4 something. And then we just go from x equals 1 to 7, right, the length of the width. We'll keep adding that 1.4. And if it's ever greater than 0.5, then we know we need to go to the next line. And I think it's actually 7 divided by 10. Let me try that instead. Okay, so 7 divided by 10 is 0.7. So that's greater than half, so we know we need to go to the next line. Then we subtract 1, so that's negative 0.3, and add in point again, so we know we need to go over. I don't know, let's actually work on the code in that. We can actually do it there. So we're first going to take the width, divide it by the length, we need to store that as a decimal value. Okay, so Lou is good. It doesn't round for us. If we look at triangle, I just told it to do a draw triangle 10 length, 7 width. And triangle, and now it just prints what that value is. So let's say the, what am I going to call this? Maybe like the, alright, it's called slope, or just S. Width divided by the length. Now we're going to move from one to the width. And we want to call turtle dot place up. So it's going to put one above him. And then we're going to say, we need to stir the current current slope, like where he is. Current S equals the current S plus the new S. So we're incrementing 5.7. Okay, rather than struggle with math, I just went around, tested it, make sure it worked, and I'm going to go just explain it instead. So the first thing he's going to do is draw a straight line. That's the length distance. And then he's going to find that slope between the width and the length, assign it to the current value to 0. And then he's going to go from I equals 1 to length minus 1. And why did length minus 1 is if you do it to length, he goes too far past where you want to draw. So that's just something in testing I know I needed to go 1 less than the length. And he's going to place a block up and move backwards. And then what I do is I add the slope value to the current value. So on our 7 and 10 example, 0.7. So it's going to be 0 plus 0.7. And if now that new value is greater than 0.5, so that means it's at least halfway over to the next block, then we're going to round up, basically. And we're going to turn our turtle to the right, move him over, turn him back to the left. So that's just moving him over to the right. And then we're going to subtract 1, because now we moved over our coordinates, so we're kind of in a new scenario. And then we just go ahead and keep doing it and keep adding. So the first time we got to 0.7, we're going to subtract 1, we'll get negative 0.3, add 0.7 again, you get 0.4. So this time the 0.4 is not greater than 0.5, so he won't move over. He'll just move down 1. And then the next time you add 0.7 to that, and you get 1.1, which is greater than 0.5. Don't worry about the math if it's not understanding it. There's a great website, if you look up the Bresenham's line algorithm, it tells you all about how to calculate it. Okay, once he does the slanted line for the triangle, then he's going to draw to the left a line equal to the width, and then he's going to turn right again so he's facing the same direction. So, turtle, you're drawing with leaves again. Give me a 10 by 7 right angle triangle. 8, 9, 10. Now he's going to try and do the slope line. Awesome. And as you've ever, tried to make a diagonal line in Minecraft, it's pretty difficult, so that turtle did pretty well. Oh, I think he ran out of leaves. Aw. Okay, so, cool. So let's make a bigger one. Let's go height of 20 something. And let's make this 12. So a really slanted line. And we need to give him a lot of bricks for that, so let's make him out of diamond. And off he goes. Fly, Funshine. Okay, that should be 22. Here he goes. He's going to make his diagonal line. Looking good. So I don't know about you, but I always am making these lines and having to look up or just kind of eyeball it is pretty tough. But he did an amazing job. Good job, Turtle. And there he goes. There's our triangle. Cool, huh? And now the last one would be the circle. Okay, the fun one, draw a circle. I hate drawing circles in Minecraft. You always have to like put it into Excel or pixel art or something and figure out where the circles go. So we're just going to give us a radius. That's the only thing we're going to care about. And if you look at the midpoint circle algorithm on Wikipedia, it's easy to see that a circle is just a set of four, fourth of a circle, and even you break that up into two more, so an octant, so an eighth of a circle. And you can see if we move over, every single time we're going to go forward, and then every once in a while we'll go left as well. So very similar to our line drawing algorithm. And you can get the rest of the math here. Fun stuff, huh? But they give you code as well. So I'm just going to be taking note that this is 0 and 0 because we're starting at where he currently is. And so basically we're just going to use a lot of this code from Wikipedia midpoint circle algorithm. Okay, so I went with a different algorithm that draws an entire quadrant instead of just an eighth of the circle because that was proving too different. So here it is implemented and tested. So since we're doing an entire quadrant, I'm going to do this 4 times. So do a loop 4 times. Set some initial values, and then just do this while loop. And every time y increments, so we're going over in the y direction, we want to turn him to the right, go forward, and then turn back to the left. So he's always facing the same direction, but he's moving over to the right. And then every time the x increments, we just want to back up one, because we're kind of going down. And then when we get to the end of that quadrant, we'll just turn him to the right, and in effect that turns the world to the left in his frame of reference, and then we just repeat that exact same, and he'll draw the 4 quadrants. And that's all there is to it. It's pretty simple to get a circle here. So let's go ahead and test it. He's set to draw a, let's check, radius of 8 circle. And he needs some stuff. You can see some of the failed ones over there. Well, they're not failed, but this one he ran out of stuff, out of diamonds. And this one's I didn't have the center set correctly. But they are some good circles. Oh yeah, there were 3 turtles and they ran into each other. Let's see how this guy does. Looking good. I mean, each algorithm has to round to the closest pixel because these are, Minecraft blocks, not individual little dots. So you're going to get slight variances in each little algorithm, but this one's pretty good. I mean, that kind of looks like a circle from far away. This one's actually looking really good. Let's just let him finish up. So some things I'd like to do to finish this off is the first one is handle the case where he runs out of blocks. So we'll do that. And also, I don't want to have to edit the circle program every time. There he's done. Cool. So if you'll see, if you'll notice this guy, I have to always say, come in here and change the size of the circle. I don't want to do that. What if I could just say circle 2, or 3, or 4, or 100, you know, and he would just know that's the radius. So we know that works because things like copy, you can then pass parameters to. And delete works the same way, and there's other ones that work that way. So how do we access that? Well, when you pass, anything you type in after the name of the program goes into a special array called dot dot dot. I don't know what the actual name is of it. Hold on. Alright, turned on MSN off. So it's in this basically ellipse array, and if you go like this and set that equal to something, like the arguments, now we've got a table of all the arguments that are passed in. So I can now do ts draw. Actually, I'm just going to comment this out real quick just to test it. And let's print argument, the first one. And if I do circle, nothing gets printed, but if I do circle 10, you'll see 10 gets printed. And I can do print arg1. That just means put a space in between these. And it'll print off the arguments. So let's now use that knowledge instead of print, pass it in right here. And we should probably check that it's not equal to null, but we don't really need to, it's just demonstration. So let's try a circle radius 4. It's probably going to run out of diamonds. But it's going to be a pretty small circle. There you go. So even small circles look pretty good. Okay, so let's handle the case where he runs out of blocks. So we can come here and let's go down to the circle program. And every time that we do turtle.placeUp, which is just one time, I believe, yeah. Let's do this and call turtle.placeUp. Let's just call our own placeUp. How about that? And in this one, we can call turtle.placeUp. But before we do that, let's check and see. Right, pseudocode say if current slot is empty. Select next slot. Or select the next one that has stuff in it. So, okay, so there's no real way to know which slot we currently have selected. So I think the easiest way to do it is going to be do a loop and say for I equals 1 to 16. Oops, need a do on there. If turtle dot get item count is how we tell how many things are in a slot, and pass in I. Oops, we don't need quotes around there. That's my C# stuff coming through. The item count I is greater than 0. Then turtle.select and return. So we're going to start 1. That's got space, we'll select the first slot and return. If that's empty, then we'll try space 2, and so on and so forth. So we're going to check that every time we go to place a block. Oh, and we don't want to do return because we need to actually place it. So instead, let's do a break. And that'll just break us out of that for loop. And then it'll come down here. So get rid of this comments. And let's go ahead and test him. So we got some good space. Let's give him 4 diamonds, 1 gold, some stone, and a ton of iron. Circle 5. Here he goes. So he should use the 4 diamonds. Now use the gold. Now he's using the stone. And now the iron. So that worked perfectly. Now we can just, if we're drawing a super big circle like this one, we can just give him 2 stacks of diamond or whatever we're building with. And he should be able to complete the circle. If you're building such a large circle that you can't even get around it, I don't know, maybe call a pause or a stop or quit the program so it doesn't keep driving. But that's, things they could do with this API. This API is nowhere near finished. You wouldn't want to publish this to the world as an API, but as a learning experience, I think it was a good way to learn how to write APIs and some more things that are possible with turtles. Obviously, this could save you a lot of time if you need to build like a tower. So I think let's do that. What we're going to have to do is, let's go, I'm going to build a pillar real quick. I'll have to get rid of some of that. And then place turtles here. Let's make it out of netherrack. Give them each 2 stacks. And let's make the bottom 2 actually out of something else, maybe where's another brick? There we go. Okay. And remember, turtles place above them in our API, so we need to start the top one first. So let's do him a circle 5. Do 1 with 6, another one with 5. Eight. 9. And watch them go. Oops, looks like forgot to give 1 layer. Looks like they might run into each other over here. Hurry! Yeah, he's gonna run into problems. Oh, maybe not, maybe not. Oh yeah, those 2 couldn't complete their circles. What are these ones doing? Oh, they're still going. Oh, they must have ran into each other because they're way off. Yeah, they got messed up a little bit. So it might have not have been a good idea to start them all right together, but as you can see, you could build a tower pretty quick. A lot quicker than you could normally. So that makes turtles awesome builders. I had a lot of fun with this tutorial. I know it went pretty long. Thanks for sticking in and watching it, guys. And I really appreciate everyone that watches my videos and makes the awesome comments and clicks like and subscribe. And I've been blown away by your guys' support. So keep letting me know what you guys want to see. Some of the next things I plan to do are cover the graphical GUI. This lets you draw on monitors in color. So I know some people have been asking, how do you do color on monitors? And there is a way to do that with a special add-on. And the other thing I plan to do is do some like menus or graphical interfaces, because those are usually pretty necessary if you want to make a nice program to control a bunch of machines or something. You don't want to have to type in everything. You'd rather just use your mouse and enter key and that kind of thing. So those are my two next ones I plan to do. And if you've got more ideas, let me know. I know someone wanted me to make a nuclear power controller, and since I've really never worked with nuclear power in all of my Let's Plays with the technical mods, I think that's a great idea, so maybe I'll put that one in there as well. And until the next time, this has been FunshineX. See you guys later. Bye.